In 2007, Wesley Autry was waiting for the subway in New York when a stranger had a seizure and fell onto the tracks. With the train approaching, Autry didn't hesitate. He jumped down, pinned the man between the rails, and let the train pass inches above them both. We often treat this kind of self-sacrifice as a rare exception to a cynical rule. There is a prevailing idea that humans are naturally selfish, and that we only act with kindness because civilization imposes a fragile set of social rules upon us. By all different origin. In split-second rescues, the conscious brain doesn't have time to weigh social consequences or moral rules. The impulse comes from a biological circuit that we inherited directly from our mammalian ancestors. If heroism is a hardwired instinct, it changes the way we look at our own species. It suggests that kindness is a baseline setting, and the mystery is why our modern world so often seems to suppress it. This creates a massive problem for the math of evolution. If natural selection favors the fittest, it should technically punish anyone who risks their life for others. A gene that causes you to sacrifice yourself for a stranger should, in theory, go extinct. For decades, science relied on kin selection to solve this, the idea that you help relatives to ensure your shared DNA survives. But Wesley Autry wasn't related to the man on the tracks. That theory cannot explain why we risk everything for a genetic stranger. There is also reciprocity, where you help someone today, hoping they'll pay you back tomorrow. But that logic ends the moment the help becomes life-threatening. If you die in the rescue, you'll never collect the favor. Neither theory accounts for extreme altruism. To find the answer, we have to look for a hidden mechanism that allows these seemingly selfless genes to survive the brutal math of evolution. This research highlights that human infants as young as 14 months old will spontaneously help adults reach for out-of-reach objects. They do this without rewards or prompts. We seem born with a drive to be helpful before we even understand social norms. We see this across species. In 1996, a gorilla named Binti Jua rescued an unconscious 3-year-old human boy who fell into her enclosure, cradling him and carrying him to a gate where zookeepers could reach him. These sketches show the behavioral link. The same neural circuit that drives a mother rat to retrieve her crying pup fires in the human brain when seeing a stranger in distress. Our heroism extends from the primary mammalian drive to rescue helpless offspring. This graph from a 1969 study shows the power of that drive. A mother rat was willing to press a bar hundreds of times, over 3 hours, just to retrieve pups that weren't hers. She received no reward, yet she continued until she was physically exhausted. This reveals the biological truth. Human heroism isn't a modern invention. It is the result of an ancient mammalian system, originally designed to save babies, being applied to the wider world. But the math still has a gap. If this instinct is so costly, how does the gene survive where selfish actors simply take the help and offer nothing in return? In the public goods game, an isolated helper among selfish actors is drained until they disappear. Survival depends on positive assortment, a rule where helpers interact mostly with each other. When helpers cluster together, their shared benefits outweigh the energy lost to outsiders. Evolutionary success doesn't require being selfish. It just requires being part of a group where your cooperation is met with more cooperation. When helpers find one another, the math of cooperation dominates. The collective advantage of a clustered group allows the altruistic gene to outcompete selfishness. But under negative assortment, where a helper is isolated, cooperative behavior cannot sustain itself. The blue line drops to 0. This math has a psychological equivalent. When people are isolated in environments that reward exploitation, they face burnout. Without a cluster of other cooperators for support, the drive to help eventually goes extinct in that group. Kindness is a powerful force, but it is environmentally dependent. If we build systems that isolate helpers, we effectively code cooperation out of existence. This science changes how we approach leadership and social design. If we want cooperative workplaces or societies, we have to move past simply asking individuals to be better and focus on building structures that group cooperative people together. Because the math of assortment depends on clustering, our infrastructure matters. Digital platforms and city neighborhoods either facilitate supportive clusters or they isolate us. When we design for connection, we are creating the mathematical conditions for kindness to survive. We are born with a biological system primed for care. It is a core part of our evolutionary heritage that existed long before we had social norms to define what was right or wrong. Risking ourselves for a stranger isn't an evolutionary error. When we create the right environment, that ancient mammalian drive to protect others becomes the most powerful thing we have.